Hello everyone, it's Dr. C. What I'd like to do in this recording is cover a very important problem-solving technique that we will use a lot in this course. We've talked a little bit about this in class, but we're going to practice this more and more, and we will see this technique, dimensional analysis, what we also call unit analysis, quite often in this course. For stoichiometry, for lots of other calculations. So it's important that you really get a handle on it now. And the reason why I like to call it unit analysis rather than dimensional analysis, it really comes down to just watching your units. If the right units cancel and you end up with the correct unit, it's a good chance that you set the problem up correctly. So we're going to start with some given unit, and we want to get to some other unit. Let's call that our desired unit. And so we are going to set up some conversion factor in which we arrange that conversion factor so our given unit cancels, numerator and denominator, and we end up with the desired unit. Okay? It's all about canceling units and ending up with the units you want. And if you do that correctly throughout, you do have to set your conversion factors up correctly, you should get to the correct answer. So let's start with a really, really simple one. And I'm going to start out with one in the US wacky system of units, and we'll do a metric one next. But let's say, and you're going to say, Dr. C, I can do this without setting up a unit conversion. But let's do one that's really, really easy, and then we can see the process by how we do this. So let's convert 24 inches to units of feet. Okay? And again, you're going, I can do that. Well, let's look at the process of how to set this up. So, we want to start with our given unit is inches. Our desired unit is feet. So we need to get inches to cancel out, and we need to end up with feet. So we have to come up with a conversion factor. And where we're going to start is we're going to start with an equality. And that equality, you probably know, that there are 12 inches in 1 foot. Okay? So there's our equality. Now, from that equality, we can write two conversion factors. As you get better at this, you will automatically see which conversion factor you need to write. But for sake of argument, let's write two conversion factors and then decide which one we need. So we can take what's on the left of that equality and put that in the numerator, and the other in the denominator to make a conversion factor, or we can switch those. So the two conversion factors would be 12 inches over 1 foot. There's our conversion factor. Or we can switch that and put feet or foot in the numerator and inches in the denominator. That's simple. So there are two conversion factors that we write from that equality. Now, we need to decide which of those we want to use. And since we desire the unit of feet, let's choose the one that has feet in the numerator. Okay? So if I write that one in, okay, now I can get a different pen here. My given unit cancels. Unit I'm left with is foot or feet, and it looks like I have gotten to my desired unit. And if we do this calculation, and you knew the answer anyway, 2 feet. All right, so pretty simple, but the thought process, really try to wrap your minds around this thought process so that we can then expand that to more difficult problems. Sig figs, which we've talked about, 24 has two significant figures. So we carry two significant figures in our answer. This conversion factor is an exact conversion. There's exactly 12 inches in a foot, so we have an infinite number of significant figures there. So don't worry about that. All right. Now you might want to write out this conversion factor using this other conversion factor, just to convince yourselves that will not work, because you're going to get units of inches squared in the numerator, inches squared in the numerator and feet in the denominator. Your units are not going to cancel out and work out to your desired unit. All right, let's move to a metric example. Okay, so here's my next example for you. Let's convert 318 microseconds, so make sure you recognize that metric prefix, micro, to seconds. Now you do need to know these metric prefixes, and for some reason in the US we have not really adopted the metric system, but you do need to know these. We will use these extensively in this course. So we need to start, well, let's start with microseconds. We want to end up with seconds. Now let's go to the equality that we need to write our conversion factor. So 1 microsecond. What does that letter micro mean? What number does that stand for? And we know that that letter just means 10 to the negative 6th. So there's our equality. So make sure, if you're not good with the metric system yet, that letter just represents that number. And we're just kind of, rather than having to write that number each time, we can just write a letter to represent that. It makes our lives easy. All right, so there's our equality. 1 microsecond is 10 to the negative 6 seconds. Let's practice writing to conversion factors. Okay, so take that equality, switch what you have in the numerator and denominator to make 2 conversion factors, and then decide which one you need. Well, we desire units of seconds. I think it's pretty clear that we need the one on the right. And if we write in that conversion factor, microseconds cancel. We're left with the unit that we want, seconds, and do this calculation, 3.18 times 10 to the negative 4th seconds. All right, not so bad. But you do, there's a lot of things you do need to know. You need to know the metric system here. You need to know how to set up your conversion factor to get your answer. All right, let's do one more problem. Well, actually, we're going to do 2 more, but I have 1 more prepared, and then we'll do another one just so we can practice with squared or cubed units. All right. So the next one is going to have more than one step. You can see that these first 2 conversions that we have completed, we only had to come up with 1 conversion factor. Well, some calculations, and I don't know where my question went. I had a second question there. All right, sorry about that. The problem had scrolled way to the bottom of the page, so it took me a while to find it, but here we go. So here's a problem that has some units you may or may not be familiar with, but we're talking about oil in Prudhoe Bay, Alaska. There is about 9.6 billion barrels of oil there. What would this be in cubic meters? All right, so you're probably not familiar with barrels, so a lot of times you're going to have to look up these things. Google is a great thing, right? You could just Google how many gallons in a barrel or whatever. But on problems like this where there are conversions that I don't expect you to know, I will put them in the problem. So you will see that there are a number of equalities put in this problem. 1 barrel is 42 gallons, that's exact. You probably knew that 1 gallon is 4 quarts. And then, of course, you would not know how many meters cubed are in a quart. And there would be other ways to get to meters cubed, but let's go that way. So now let's write out our plan. We're starting with barrels. Okay, 9.6 times 10 to the 9th. And we want to get all the way to meters cubed. So a lot of times you can look at those equalities that are given and help you figure out how to get there. All right, so I have this first equality that will allow me to get to gallons. And then I have a relationship between gallons and quarts. And then I have a relationship between quarts and meters cubed. All right, so we're going to have to do 3 conversions to get to our answer. So let's just go ahead and get started with that. So at this point, I'm not going to write out 2 conversion factors for each equality. We're just going to write 1. but we're going to look at what we need to cancel and where we need to go to set this up correctly. All right, so we want to get to gallons. So look at this equality, 42 gallons. So we're going to put gallons in the numerator, and we're going to put barrels in the denominator. Okay? Barrels cancel. Okay, there's one conversion. Now we need to get from gallons to quarts. Look at the next equality. We want to get to quarts, so let's put quarts up in the numerator, gallons in the denominator. We need that to cancel. And just write in the numbers. 4 quarts is 1 gallon. All right, not so bad. And then, last step, we have to get from quarts to meters cubed. So we are going to put meters cubed up in the numerator. That's our desired unit. The unit that we want to cancel is quarts. And then let's just write in what we know. 1 quart is 9.46 times 10 to the negative 4th meters cubed. Quarts cancel. All right, so let me grab my calculator here. I'm going to take that 9.6 times 10 to the 9th. We're going to multiply by 42. We're going to multiply by 4. And then we're going to multiply by 9.46 times 10 to the negative 4th. And let's see, how many sig figs? Looks like 2. I come up with 1.5 times 10 to the 9th meters cubed. All right, there you go. Not so bad. So again, you do need to know your metric conversions, probably some other pretty straightforward ones as well. Ones like these I would tend to give you, and that will help guide your thought process on solving a problem like this. All right, the last thing I want to do in this recording is I do want to talk about, sometimes you'll have to, even though we saw meters cubed, we didn't have to actually do anything with that unit in terms of cubing it to get to where we wanted. But what if we had something like, and let me see if I can get myself a little bit more space here. Okay. Sometimes computers do weird things to you here. Okay. So let's say we had 24 inches squared. So let's work with squared, and we'll do a problem with cubed in class. And then let's say we wanted to get to centimeters squared. Okay. So what do we need to do that conversion? It's a little bit different. We still need to start with an equality. All right. And I'd probably give you this one. You might know this one. You might not. There are 2.54 centimeters in 1 inch. All right. So we need to write a conversion factor. And let's go ahead and write the 2 again, just so we can compare. So we can put 2.54 centimeters in the numerator, inches in the denominator, or let's flip that. All right, and then look at which one we need. I think it's pretty obvious. We want to get to centimeters, actually centimeters squared, but this looks close to what we want to get to. All right, so I'm going to try that. All right, did that get me to what I want? Did that get me to centimeters squared? And you're probably thinking ahead already, but this inch will cancel with one of the inches squared. Remember, inches squared is inch times inch, so we cancel one of those. So now we're at units of inch times centimeters. Is that what we want? Not quite. So what do we need to do? Yeah, we need to apply that conversion factor again. Okay. Now, inches will cancel, inch in the denominator, inch in the numerator. Or if you want to look at it, we now have inch times inch, it's inches squared in the denominator. That will cancel. Centimeters times centimeters is now centimeters squared. All right. Multiply that out. And to two significant figures, because we only had two significant figures in 24, I'm going to have to write this in scientific notation because I came up with about 155, but we only have two significant figures. I actually have 154.8. So to two sig figs, this would simply be 1.5 times 10 to the second. Okay? It actually came out to be 154.8, right? But two sig figs we're going to have to round down in this case and write in scientific notation. Make sure you take a look at that. Now, how would we actually write this when we become better at doing this conversion? We actually wouldn't have to write this conversion twice. We would simply go 24 inches squared times 2.54 centimeters per 1 inch, quantity squared, and then get our answer. But be careful. When we have that squared term there, we are not only squaring the units, but we also have to square that 2.54. All right? So it's very easy to forget to square the number within that parentheses, but be careful. We're actually squaring the 1 as well, but 1 squared is just 1. All right. I hope this helps. We'll practice a few more of these in class, or at least one more. If you have any questions on these that we've gone through here in the recording, let me know at the start of class, and I can clear some things up, and then we'll do at least one more example of dimensional analysis. Again, really work on these, practice these, do these in the homework, and really get a handle on these early in the semester, and then you should be, 80% there, and most of the math we're going to do for the semester. All right? All right, I will see you soon in class. Take care.